And we're live. All right, everyone, thanks for joining live with us. Thanks for joining remote. We are super excited. I think this is our 14th computer over data remote session. So we are very proud to welcome the new Atlantis DAO team, and also the Polybase team is joining us today. Much love for the people building in the space and the people building on top of Bacalhau. Let's start with just a brief advertisement. We have Compute Over Data Summit coming up here. It's going to be May 9th through 10th. So if you haven't submitted a call for paper, we'd love to have anyone in the community talk at the event, promote the work that you're doing, or if you're a user and you have use cases and you need to build on top of decentralized and compute over data solutions, we'd love to have that as well. Or if you just want to attend and just kind of get up to speed what's going on, please have a look. And if you have any questions, send us a note in the channel. All right, that's all for the advertisements. Stanley, thank you so much for kicking it off for us. I'll hand it over to you and let you tell us more about New Atlantis DAO.
Yay! So excited to talk about New Atlantis DAO today. Thank you guys for having me. And as a data scientist, thank you for, I know I'm going to say it wrong, Bacalhau. Bacalhau, have been wrangling complex data systems for most of my career, and a lot of times it's painful, and a lot of times like you don't feel like you're putting your work in where it would serve the best purpose. And I think that what you guys are building is going to do so much to help address that. With that being said, let me dive right in. So we will be exploring New Atlantis's first decentralized protocol tool, and telling a little bit of the New Atlantis story, and then explaining how open protocols on decentralized compute are something that we feel is going to be key to saving our oceans. So just to kind of set the table, if you see my screen, I am here logged into the New Atlantis Cloud Lab, which is at lab.newatlantis.io. And that is our access point to the New Atlantis Research Cluster. Our goal is through this lab to integrate every tool, data, and resource needed by marine scientists so they can do their work unencumbered. And we're looking at the first fruits of those labors right here. So anyway, we'll be going through a little presentation about New Atlantis that will then return to the particular tool we've been building. And we're right here in the New Atlantis protocol notebook. So this would be the sort of the part of the decentralized protocol iceberg that for us sticks up out of the water and is where scientists can access, learn about, and work with the protocol. So the protocol that this little discussion will orbit around, just to give it a little intro, is called Human. And it is a traditionally clinically applied metagenome analysis pipeline that lets you take a complex population of microorganisms and actually see what they're doing chemically. There'll be more of a chance to talk about this, but just to kind of review, we got all of our code here nicely hidden. And that's a little bit of the idea, to let the scientists focus on the science. Anyway, on to the presentation and our demo. So here we have, the interface for accessing the protocol, and then I've also snuck in my my presentation slides right here inside the presentation. So hey, welcome to New Atlantis DAO, and our mission statement. New Atlantis seeks to address the twin challenges of climate change and biodiversity loss by aligning community, government, industry, and individual benefit with the improving ecological health of our oceans. The healthier our oceans become, the more value generates for relevant stakeholders. And how are we going to do this? Well, it's the DeSci ethos, right? It's the idea that all of the resources are on the table to solve this problem, and it's about connecting the dots. And it's about getting people from very different backgrounds working together. So our core constituencies are scientists, technologists, and business and economics leaders. And New Atlantis wants to be there right at the center, developing the tools and scaling the tools to create a leading open marine biodiversity data platform that will harness the collective intelligence of all of these global communities. But why? But why? And forgive me if this part gets a little scary. We are headed towards a cliff, y'all. Don't mean to be morbid, but for the duration of this presentation, half of the breaths you take the oxygen was created by the plankton in our oceans. And the plankton are out there every day working hard for us, but they're under a lot of pressure. The ocean is warming. This greatly throws off the interactions between the different species that are, doing work for us out there in the oceans. And we don't got the foggiest idea how fast the bottom could fall out on this, or how close we are to the edge. And so, for example, one of the big things that's happened for me this week is, you can see right here, there was a fairly alarming article in the Washington Post that shows that this year in particular, we're experiencing unprecedented warming. And it's to a point that is bringing up a lot of concern on the implications on the health of, the planktonic community in the oceans, which, is kind of the foundation of both the air we breathe and the food web that we're, perched atop of. So anyway, how do we deal with this, right? Well, the first way to treat a sick patient is to, gather data and do some tests. And that's what New Atlantis is here for. So right now, I'm just going to say a little bit about what metagenomics is. So, imagine grabbing a glass of ocean water. How many different species of microorganisms are present in that water? How many fragments of DNA from fish and whales passing through? How much bacterial DNA is in just that glass of water? Well, it turns out a whole heck of a lot of DNA is in just a single glass of water. And in the same way, you can take a patient's blood to understand the state of a patient. You can do the same with the ocean. So here is just a little caricature of what our pipelines look like. We imagine here on the left is a little drop of water with biological material from all the critters that are part of the ocean. The DNA is extracted by scientists to create what are called raw reads. So these are little puzzle pieces or fragments of a total genome. And then the computers, and of course, here there's quite a bit that I'm glossing over in this slide, put it all together into the full genomes. And then we get the ability to see, understand, and explore the state of this incredible food web that we rely on. Let me tell you, though, it ain't easy. So if you see my screen right here, we have the very rough topology of our alpha metagenome pipeline. So the data from its raw read form has quite a journey to come out the other end as actionable insights. And if you've ever done data science in bioinformatics, this is standard. And in putting something like this together, you will encounter versioning issues. You will encounter computational runtime issues. Bioinformatics as a field of computer science is actually one of the least stable, and for very good reasons. It's one of the hardest. You need to coordinate execution of the most complex computational software, the most complex scientific software. And then a lot of the databases and the tools are stored all over the place. So I have to say, I think this slide was masterfully done by our head of community, JJ. This is the topology of a metagenome project before Bacalhau. And I know any technologists in the audience know what it feels like to hold something like this in your head. Where's this piece? Where's that piece? Did they update this database? Is the new database on the FTP? Is the computer? Oh my goodness, it gets kind of crazy. And I have to say, I'm always just so impressed that in the sort of traditional scientific computing paradigm, any of this is possible. It's only through great work and dare I say, genius on the part of our scientists. But it doesn't have to be this way, thanks to you guys. So here is the New Atlantis Open Cloud Platform solution. So the first step is to gather our data sets and our databases and our tools and make sure all of those are registered, validated, and filed on IPFS or a similar decentralized data solution. The New Atlantis Cloud Lab, which I'm logged into right now, and I will soon start running some protocols on for our demo, interfaces with the data through a COD paradigm with dispatch from the Cloud Lab. So scientists get to work within the tools they're familiar with, electronic notebooking systems like Jupyter, and they have ready access to dispatch their protocols to a backend flexibly, and they can take advantage of things like the Bacalhau backend. And this is so important from a stability perspective, but it's also very important from a transparency and a validation perspective. In order for these tools to be used ethically and not subverted, everything about their accuracy and the quality of the data going into them will need to be transparent. So, just this mission aligns so well with the principles of decentralized science and Bacalhau. Anyway, I hope that was all right. On to the demo. So forgive me, I am not the UI guy. I'm definitely Mr. Backend. So this will be my best caricature of something fancy. But hey, right here we have our data selection and onboarding widget. And so this is plugged directly into an IPFS node on our cluster, and it allows scientists to access, generate, and onboard data sets to IPFS or a different decentralized backend. For the purposes of this demo, we'll be working with the following set of sequence read archive files. These are files that were taken from a scientific mission called Aloha that seek to capture a warming-related planktonic data set. So going on to here, we got our data atlas. So early stages of working with the system, but you'll see we have a interactive atlas with all of our metagenomes displayed on the map. So each of these boat symbols is actually a place where the scientific expedition went out, collected water, extracted DNA, generated raw reads, put the raw reads together into metagenomes, and then shared their data. But what is very important is not just the status of the planktonic population, but what factors are impacting it. And one of the biggest ones we need to learn how to deal with is warming, right? So as you can see here on the right side, we have a map of seasonal temperature variations that's been interfaced with our data atlas. So we can actually zoom in and see sequence location by sequence location, what the relevant temperature patterns are. And then here's where this gets really interesting. So on to the main component we're showing off today, which is called the Human Gene Cluster Analysis Suite. So this is a protocol that will be running on Bacalhau on each of these data sets, and that actually tells us, let's call it the economics of the local planktonic metagenome. So here's what that looks like. So here we have each of the weeks of this experiment. So these data positions were collected on a time lapse. Every few weeks, a new set of data was collected. And each week we can pull up the following gene cluster analysis. So for that metagenome collection that was taken on week 3, 2003, we get this heat map, which tells us how much chemical biological activity associated with each of these pathways happened in the planktonic community during that point in time. Wow, look how much stuff these plankton are up to. So each one of these things is a different biological pipeline, you might call it, that the plankton carry out. Each of these is associated with different biological processes. And interestingly, as an example, many of them are associated with photosynthesis. And so that's just one example. We can go through week by week and look at this heat map to understand how the biological activity of the food web is changing. So we can perform what would be called translational analysis to correlate things like, how does temperature affect the ability of the planktonic food web to generate oxygen? That would be some of these bars. To sequester carbon, that would be some other of these bars. But as you can see, it's really just scratching the surface of all of the chemistry that plankton carry out for us. Sometimes at New Atlantis, we like to joke that the biggest and most important bioreactor in the world is, and always will be, the ocean. And it's really true. You know, most of the chemistry that's ever been done in history was done in the ocean by the plankton. And it's on us to keep that going. So anyway, this is just a starting point for New Atlantis. As you can imagine, this type of science is extraordinarily complicated, and there's a large number of tools in the open and closed source that need to be made available for scientists. But this is our starting point for building a best in the world open protocol system that will be the obvious choice for any marine scientist. And we're hoping it'll lead to the kind of collaboration we need, because in order to act quickly and decisively, we're not going to be able to waste time on coordination. We're going to have to get everyone passionate about solutions, like at the table, building together. And like I said to start the talk, really grateful for you guys for building what looks like it's going to be one of the key tools for our mission. So anyway, guys, that was the presentation as I had imagined it. So thank you so much for your time.
Fantastic. Wow, Stanley, this is incredible. It's funny, because Gordon and I were joking months ago about the science bucket. You dip the science bucket in the ocean, it comes back with all this incredible information, but you've really, you've made it happen. So it's fun to see this sort all coming together. Could you say anything more? You talked a little bit about decentralized storage with IPFS was an important part of the solution for the team, and then using decentralized compute was also important. For the users of New Atlantis DAO, whether it's market participants or people that want to understand how the data is being measured, could you give any perspective on decentralization? Does that add legitimacy or trust in some sense? If it's trustless, how that infrastructure impacts the end user experience or the value of the platform versus if it were just traditional infrastructure?
Yeah. So transparency is a big one, certainly. Validation is a big one. One thing that Gordon is very passionate about is the idea that this has to be done economically. It can't be charity, like people need to get rewarded for creating value. That's the only way it's going to happen fast enough. So having things on the blockchain allows for this to be done in a fiduciary way, but there's some even more important functional things that decentralization does. When you start to talk to the scientists who are working at the top marine institutes, you really quickly discover something kind of interesting. Each institute is very specialized. So just off the top of my head, one of the big institutes has orders of magnitude more marine, call it naval capacity than the other institutes. So they have most of the data that you actually have to go out and collect. There's other institutes that specialize in the bioinformatics and the data science. So when it comes to protocols, they have the most important and interesting technologies. And then as a third example, the other main marine institute that we communicate with has the best ecological and animal specific experts. So, if you think about it, to really understand how to help an ecosystem, you need to get the data. So that's the first institute. You need to have good protocols to run on the data that can give you accurate insights. And then you have to have specialists on the animals themselves there to give insight into what actions to take based on the data that exists. So, these scientists are completely focused on pushing their particular field further. and they're not necessarily focused or having the budget to do, a standard open source code base to allow their stuff to be shareable and modular. So that's where I'm kind of imagining New Atlantis has a role to play through operationalizing these decentralized compute and data technologies. We want to set the table that is inviting to all these different scientists and researchers to come, sit down at and, scoop some of their contribution into our spicy data stew.
Yeah, if I could just add to that too, a point that Courtney and I have been extremely focused on, as Stanley alluded to, is making this a for-profit entity. But part of that means that people have to buy into it and trust it. And really the only way, because if you take a step back, the oceans are they're probably the biggest example of a global commons, right? I mean, it's literally 70% of the planet. And for, a bunch of Californians if we took the view that we can just, sort of privately determine what's valuable in the ocean and kept it all closed source, that isn't a particularly inviting stance to take, and it doesn't really invite a lot of open collaboration. And for the metrics and quantification services that we're providing to be widely considered as valid and to underpin pricing models for biodiversity credits and related risk models, you really need to have that collective buy-in. And the only way to really do that is by having broad accessibility, complete transparency, and the ability for people to participate according to their contribution. And so, the infrastructure that Bacalhau and Protocol Labs more generally is putting into place is really, I think we're starting to see the limits of all these centralized systems, whether it's banking or cloud, and that if we want to have an open and really fair system, it's going to have to be decentralized.
Well said. Yep.
Off my soapbox.
Couldn't agree more. I think
exactly.
You're definitely among like-minded folks. Now, this is fantastic. It's such a great example. Even, speaking with other folks in the decentralized science space, when we think about academics, there's this big notion of fair data access, findable, accessible, interoperable, reusable, even in traditional academia. And the examples you gave about different organizations, different research institutions working together, then the ability to scale this to participants that are outside of that community and give them the right incentives to participate. It seems like you guys have a really interesting platform coming together. So super excited for you guys.
Yeah.
Yep.
And I was going to say one last thing. Stanley uses a term, and my connection's a little spotty, so I don't know if he actually used this term or not in the presentation, but he has this concept of batteries included. And his point about the God, it's sorry, I should look at this. So I was looking up my nose while I'm talking. Sorry, my camera's too low. The idea that that these platforms can just work, and that you can allow scientists to do the science and spend a lot less time on the technology infrastructure is I think that's going to be a great accelerant. I think that'll end up accruing a lot of value both to New Atlantis and to the overall Bacalhau thesis about decentralized science and accessibility.
You're so right. I mean, we talk to researchers often, and to Stanley's point, who are starved for resources, compute resources, and maybe they get some through a grant and they try to put together cloud resources where they can. But if you could invoke that compute on demand and you could pay for it, or you could have a community component with different incentives to pay for that compute for the researcher, there's just lots of interesting scenarios that opens up for the researcher. Yeah. And
if it just works and you're not having to fiddle with it, just you load the data and it works. So,
said.
Anyway.
The easy button.
Yeah.
All right.
Yeah.
Well, thank you guys so much. That was incredible. I'm going to post some links into the Slack channel for everyone to follow up with here in a little bit. Stanley, if you want to send those my way, or Gordon, I'll make sure we post all that information for you folks. And then Sid from the Polybase team, super interested to learn more about your guys' platform, and I can hand it over to you guys if you're ready.
Awesome. Thank you so much, Wes. So welcome everyone. I'm super excited to talk about Polybase. I'll tell you a little bit about the background story of how we started Polybase. I'll tell you about kind of what it is and what problems it solves. And then I'll tell you about what people are building on top of it. And then happy to answer any questions after that. So I come from a software engineering background. My co-founder and CTO, Callum, also comes from software engineering, building developer tools. We've been building things like some of the iOS frameworks for Apple on iOS 9, 10, and 11. I was a tech lead for Hey Siri, Get Me an Uber. I then worked at Cruise, building simulation infrastructure for autonomous vehicles. And I've always had a kind of an interest in building really good tools for developers. And so when I left my last job, I teamed up with Callum and we started talking to a lot of Web3 developers. We ended up having about 100 or 150 conversations. These were kind of almost like user interviews where we started understanding what are the tools that Web3 developers are struggling with today, what are the challenges they have, and what would they like to see built. Out of that, we basically pulled out a common thread, which was Web3 developers today don't have a good database that's decentralized, that has Web3 permissions like wallet-based authentication, role-based access control built in. And so they were kind of jerry-rigging a bunch of different tools together to make it work so they could build their decentralized applications. We basically took that problem statement, wrote our white paper in summer of last year, and started fundraising. We raised our pre-seed round, and then we got to work building. We actually launched our testnet in November of last year, and since then have gotten a ton of developer feedback and interest in building apps on top of Polybase. We just completed this week our first hackathon, where we had over 75 teams building dApps on top of Polybase. And I'll talk a little bit later about what those use cases are. So that's where we are today. We have our mainnet launch scheduled for the end of Q2. That's going to bring kind of all the production level features that our customers have been asking for and be able to ship those for them. So that's kind of our founding story. Kind of rolling back a little bit, our mission is to restore humanity's control of its information. And so what that really means is that we've seen information collection and exploitation at scale, which has really kind of eaten into people's rights and controls over their own data. You think about politics, you think about commerce, you think about culture. This is happening across the field. And so our solution really to that is self-sovereign data. And our vision to solve this problem is to build a single database for the world that's developer-friendly, end-to-end encrypted, and self-sovereign. And so you can kind of think of it as the database version of Filecoin. So Filecoin is a great place to store files. Polybase is a great place to store structured, indexed, and queryable data. What we've built so far is a database that's really easy to use. And so you can use wallet-based authentication to log your users in. You can set permissions on the data in the database using things like token gating, using things like time-based access. You can do groups and roles. You can even do kind of cool stuff where an NFT can actually be the permission to access a particular set of records in the database. And the cool thing is you can actually sell that NFT on secondary markets, which makes access to your data something that people can buy and sell, which is also an interesting use case. And then the last part of it, how we make it all work, is using zero-knowledge proofs. And so the data is stored on a variety of nodes in our node network. And those nodes actually prove that they store the data, that they're returning the data in the correct way, and they're applying the correct permissions that are specified by the developer to that data, all using zero-knowledge proofs, which then will be pushed on-chain to Ethereum first, other EVM-based chains after that, and then additional chains where our customers take us. So that's kind of the overall product. I'll kind of talk about the main benefits that it gives to developers. So the first one is integrated auth and permissions. So today, if a developer wanted to create a dApp that had wallet-based login, that had wallet-based permissions, NFT token gating, they would have to use a bunch of different services. have some kind of auth middleware that processes these things and then manage that over time. Some of our customers like DAOs find this very hard to do when they have dozens of people coming in and out of a DAO, maybe doing work for a couple hours, or maybe they're long-term kind of DAO members. And so we're kind of seeing this model towards easier to manage permissions being really important. So we've built that directly into Polybase. The second is high performance at a low cost. If you wanted to build a lot of these applications fully on chain, it would be infeasible. Even on lower cost chains and scaling solutions like Polygon, it would be extremely expensive to build a lot of these systems where you have, thousands of transactions per second. You can imagine something like decentralized social where it just won't be feasible. And so the cost and performance of Polybase is very similar to a traditional database like Postgres or MongoDB. And so you're not really worried about per transaction costs, and the costs are paid by the developers, so users don't have to worry about gas fees. And then the last bit is zero knowledge proofs. And so integrating zero knowledge proofs today into applications is actually quite difficult. The tools don't really exist that make that easy. What we've done is built this directly into the database layer. So it becomes very easy to do things like cryptographically prove attributes about private data, publicly verify your business logic and show that your business logic is actually being applied to data fairly. And then all of that actually enables self-sovereign data, which means ownership and control of the data that one produces. Our API is really simple. It's kind of like you create a collection, which is a table. You create records in that collection, which are the rows of that database, and then you can query it. So very kind of simple, known kind of API way of accessing it. I'll kind of jump into a couple of the use cases that we've seen so far that have been interesting. The first one has been decentralized social. So starting kind of the end of last year when we had the Twitter takeover, people have been thinking a lot and building a lot in the decentralized social space. The problem there for developers is that if they want to build something fully on chain, it's not really scalable. But if they build it off chain, it's not really decentralized. So it's just another random social network. And so building social networks that are decentralized on top of Polybase is not only really simple, but developers get to actually deliver the USP of being decentralized and verifiable. The second one we've seen is dynamic NFTs. So we've seen people build things like verifiable credentials in a way that makes it really simple and cost efficient to update the metadata of credentials. So for example, if you had a credential where you need to update the data behind it every once a second or every minute, you can do that on Polybase without doing like a whole Ethereum transaction to update the data, or without CIDs changing, things like that. And so it's been a really interesting place for gaming NFTs, verifiable credentials, and we're seeing some new applications of SBTs as well going forward. Another and the last kind of area I'll mention is decentralized exchanges. So we've seen DEXs want to build exchanges that are faster and cheaper. Today, building it all on chain again is extremely slow and it's expensive, and so it limits the transactions per second on exchanges. We kind of see Polybase as being really foundational to building exchanges that are open, but also extremely efficient and fast. And then the other really cool thing is you can have an order book on Polybase, and you can have the routing and the matching for bids and asks on Polybase as well. And that can actually be proven with a ZK proof that a particular order came in and it was routed through the routing algorithm in a fair way. And that's something that we haven't been able to do with off-chain exchanges ever before. So yeah, that's kind of some of the use cases there. I will do a really quick demo of Polybase. I'll show you guys the Explorer, which is kind of the admin console. Okay, so this is our Explorer. The first thing you'll notice is the root hash. This is the root hash of the rollup for the full Polybase database network. And so this is how you can kind of prove that the data that we say that's in the database is actually in there. We'll be actually rolling out more ways to validate and verify this proof as well. Then we have the collection. So these are the tables that that developers have created on Polybase. We'll actually go into the studio. You can see a bunch of my test collections here. We'll kind of jump into the verifiable credentials. And here you see the schema. So this is an example of how you would write the code for a Polybase collection. The schema will be public, so anyone can come in and verify what the database, how the database is created, but also how particular rules are applied. So for example, some rules are this public directive on the traits collection basically says anyone can read these traits. It's a publicly accessible table. And then these would be the columns of a particular table. So you can kind of see there's trait type, value, public key as well. Here again, we have a public directive on the verifiable credentials metadata. And then down here, we have something interesting called a call directive. You can set that to a particular public key. You can set that to token ownership. There's different ways to delegate the permissions here. But what this means is that if I take this out, this basically means that only a person holding this, being able to sign with the private key that corresponds to its public key is able to add an attribute to the metadata here. And so we basically go in, we check the public key equals the signer's key. If it doesn't, permission denied. Otherwise, we can push the attributes into the array here. What this does is allow us to build up really complex permissioning models that are publicly verifiable, publicly accessible, and then kind of build these autonomous systems on top. That's all I have to share today. Would love any questions or comments. But yeah, that's the end of the presentation.
Fantastic. Sid, thank you so much. I love the capability and the vision that you guys have. It seems like it's a very hot space right now, both in terms of expanding the capabilities for smart contract developers to these more sophisticated services, and also just in general, kind of offering that like for the community. They want to build more robust applications and those sorts of things. Do you see from your team's perspective with the ZK rollups, that ZK rollups are very, very popular right now? Is the goal to sort of maintain the indexes and the data sets sort of within the Polybase node network, and then use the ZK rollups as sort of a layer of verification for the users in case they need to verify it? Or how does that architecture evolve over time for you guys?
Yeah, I didn't really go into the architecture, but we do have a white paper that goes really deep into it. The high level is that the architecture is split up into 3 sections. The first is the actual storage layer. Right now, Polybase is running all the nodes that actually store the data, but we're building a pluggable system. And so you'll actually be able to store data on Filecoin, store data on private databases. And then the second part of the architecture is the rollup, which actually takes that data, whether it's public or private, and then applies the ZK rollup as well as the permissioning system to that data. And that's what brings public verifiability to even private data. And then the last part is the peer-to-peer network of clients. And so you might have someone running a Polybase like SDK client on their phone, on a React web app, anywhere, server side as well. And that's all run on a peer-to-peer network. And so all the data is actually being shared. Actually, we use libp2p under the hood. And that's actually why Protocol Labs ended up investing. But that network basically allows for sharing without any intermediaries.
Fantastic. I love it. So this is helpful because, a lot of us, you're building these primitives in the space. A lot of other folks are building decentralized compute, decentralized databases, decentralized storage. One of the things we think about a lot is workloads and growth and sort of driving user adoption. Have you guys learned any lessons about, as you're building out your product and you're taking it to market, things that work well that other folks in the community should think about emulating as they're, trying to raise awareness among their user groups and how to make it an easy process for those users?
Yeah, I mean, our North Star has been like as a developer, you shouldn't have to think about any Web3 specific concepts or technologies in order to use Polybase. And I think that's a good North Star for everyone to kind of keep in mind, which is most of the Web3 developers that are going to be in the ecosystem, let's say 5 years from now, are basically Web2 native people, right? So what we've done is, for example, the Polylang language that you saw is basically JavaScript with a couple decorators. The API is basically exactly the same as Firebase, which every Web2 developer knows how to use already. So our focus has been very clearly on the developer experience being as simple as possible with the minimal amount of new concepts to learn. What we've actually seen has been a problem in Web3 infrastructure is that I think projects end up building really generalizable, generic solutions, but then the concepts are really hard to understand. And from a developer perspective, it becomes really hard to use and integrate. And then it takes a long time to kind of backfill the usability side of it. And so we've kind of taken the opposite approach, which is like make the interface extremely familiar and then do the magic behind the scenes and allow people to prove it if they need to.
Well said.
I think there's a comment here in the chat.
There is Benjamin's asking, there's some work he's doing with Bacalhau Bootstrapper, if there's some time at the end. Yes, absolutely. Yeah, so Benjamin, let's absolutely save some time. I think we might have a little bit, which is great because I love, folks, this is time, let's use it. Let's find out what people are working on in the space. And then just to recap, if anyone else has questions for Sid in the Polybase team before we transition, and if not, I do have one last question for you guys. Sid, before we let you go, I'll just give everybody a half second. They have questions. If not, obviously we'll tag you guys in the Slack channel for Computer Over Data Working Group so that people can ask additional questions. One follow-up for you though, Sid, before we let you go is if folks want to get involved in Polybase, they want to start using the product, what's the best way for them to get onboarded? Do they go to the website? Should they reach out to you? What should they do there?
Yeah, totally. Our testnet is live. It's free. You can play with it, create collections and all that. If you have specific use cases you're interested in using, definitely reach out to me. It's sid@polybase.xyz. We've been working both like top down and bottom up. So a lot of developers coming in naturally, but also we have a lot of partnerships we're building with enterprise for specific applications. So I'd love to hear what you're building.
Fantastic. All right. Thank you so much, Sid, Shaki. Appreciate you guys immensely. Love the product. And more to come. We'll post some notes here in the Slack channel shortly.
Thanks, Wes, for having us.
Absolutely, we appreciate it. And then Benjamin, hey Benjamin, if we've got about 10 or so minutes, if you'd love to give us just like a quick kind of recap of Backboot and particularly what problems you're trying to solve with Backboot, I think it'd be a good wrap up to the session today.
Sure. Yeah, I'm not super used to talking about it yet, so a little bit of patience will be certainly appreciated. But basically, I sort of initially started writing Ansible tooling to deploy Bacalhau clusters, or not necessarily clusters yet, but groups of individual Bacalhau nodes. And as I was sort of getting into it, I started thinking about like, oh, it'd be cool if this was like sort of like a first-class citizen way of deploying Bacalhau. Like it would be cool if this was the way to do it. But I quickly realized that sort of starting an install guide with, okay, now you have to install Ansible. Okay, if you want to install the latest Ansible, you've got to use pip3. If you don't have pip3 yet, you've got to install pip3. It starts to become too many steps. And I started thinking about it. I was like, what if I just, as a really dumb idea, wrote just like a bootstrapper that would just install Ansible, install pip3 if it had to in order to install Ansible, and then it would check out the playbook, the Ansible playbook and related roles, and sort of set everything up for you and then run the playbook for you. And with the ultimate goal of just being that it would just be like one command where you just fetch the the script and then you run it, right? And it should ask you questions. It should walk you through and sort of hold your hand a little bit. Actually, I can probably even show off, just for people who are sort of unfamiliar with it. Just quickly get pulling right now. Do you guys mind if I share my screen quickly?
Yes, please feel free.
I would personally love that.
It is in a hell of a broken state right now, so I'm not going to be able to share much. But I'm in the middle of a massive rewrite at the moment, so refactor. Okay, so hopefully you can see that. But basically, Backboot, the idea is that it sort of starts off with this nice splash page. I took like these emojis from the homepage. So the emojis that sort of make up all the ways that you can use Bacalhau. I thought it was just really cool to just make like a banner out of them. So that's what I did. And then yeah, so basically, I hope it still works on macOS. I actually haven't tested this since I changed it. But it gives you like a menu option. You can sort of walk through it, and it will install whatever you need to get a Bacalhau client going. So in this case, if I just run this is going to fail. And what's kind of neat is the reason it's failed is because I didn't like have a password to run sudo. And it's nice enough to sort of tell you, hey, go ahead and try running that yourself. And so then the user can hopefully run that themselves and quickly figure out what the issue is. So it's really, really friendly as a tool. The sort of end game of the tool is it's intended to be a tool for actually spinning up entire clusters and doing all of the cloud stuff as well. So one of the things that I did today was I got cloud deployment finally working and having it actually provision and destroy DigitalOcean droplets. So it soon will be capable, or is already capable, but just I haven't wrapped it into Backboot itself yet, of deploying arbitrary numbers of DigitalOcean droplets, instrumenting them potentially across regions at some point, and then tearing them down at the end. So the future of Backboot is going to be, you'll have one command that you can run where you basically, with one command, you can spin up your own Bacalhau cluster and tell it how many hours you want that cluster for and leave it running. And it will basically come back after a set number of hours and tear down the cluster for you so that you don't have to worry about leaving it running and incurring lots of costs. So if you have like a temporary workload, really, really, really handy. And it's already pretty capable of that. I actually got nearly banned from the DigitalOcean API because I tried to spawn 450 droplets at once intentionally, just try and push it, because I have a limit of 500 on my account. So I was like, I will use all of that. And it turns out that that was a bad idea. And the really fun part is that I ended up with 78 droplets still running on my account. And because there was no API, I had to delete them all by hand using the web UI, which if you've ever deleted DigitalOcean droplets, is extremely painful. So I guess, are there any like questions about like motivations or like anything like that? Like, is anyone curious about anything about Backboot? It's still fairly new. It's still very much in development, but I was just, if anyone's curious.
I have a little less of a question, more of a comment and an encouragement. I think
Sure.
Backboot is really important to the ecosystem. I was just having an interesting conversation with David that was about like, I get a lot of inbound from data centers that want to diversify their compute offering to scientific workflows. And man, do they have weird hardware sometimes and weird kind of cluster topologies. And, having something that can flexibly and in a decentralized way mobilize thousands of GPUs that are just sitting there doing nothing could really open up, compute for science. I think it's such an important thing, and I can't wait to follow your progress.
Awesome, thank you. Well, I guess I'll sort of make a quick comment on that actually, and then probably leave it there because I think we're just about at time. Although I think we have a few minutes left actually. Yeah, so that's sort of the motivation behind the inventory feature. So it just sort of natively supports passing through an inventory file to Ansible, which is very, very easy to implement, but it means that you can sort of arbitrarily decide how you'd actually like to lay out your topology in your cluster. So when I add in support for private clusters and other things like that, it'll be possible to basically define your own inventory file that defines everything you want and goes off and builds it. So extreme flexibility is like sort of a very much a built-in feature, and part of the philosophy of the tool is to be the most flexible way to deploy Bacalhau, but also be the simplest. So it's going to do everything from I just want to install the CLI tools on my machine to I want to install it across 1,000 nodes and create like an 1,000 node Bacalhau cluster, potentially a private one. So yeah, GPU support's planned. Mounting like arbitrary file systems is also planned. So like if you want to do something like part of my motivation is I have a bunch of AMD EPYC CPUs at home, or computers, I guess. And I decided I was like, well, I would love to run Bacalhau nodes and run some of the most powerful Bacalhau nodes that I think will exist right now. But I was too lazy to do it by hand. And so I sort of decided that because I was too lazy to do it by hand, I would write a tool that would automate it all so I wouldn't have to do it by hand. And I recognize the irony of writing a tool that takes 10 times longer plus than just deploying by hand. But I just, sometimes I get angry at problems and I make them go away. And then I try to make it so that no one else has that problem ever again. And I found that can be very, very effective sometimes. If anyone's familiar with Logstash, the original author of it used to say that he practiced hate-driven development. And he didn't mean it as a pejorative, he sort of meant it with love, and I do identify with that. Like sometimes I see a problem and I'm like, I would like this to not be a problem. So I'm really, really excited. I think we're presenting Backboot at the COD Summit, the Computer Over Data Summit on May 9th. And I suspect it's going to be pretty far along by then. I'm hoping to be basically feature complete by the time we announce it. So yeah, thanks for the time. Really appreciate it.
And Benjamin, I might bug you to see if we can get a couple thousand GPUs going when you're ready.
This week I'm gonna probably have to do my actual job. Although I think the Bacalhau team is now trying to get me to some extent.
Listen,
but,
I'm a gentle and friendly person to work with, and honestly, actually, we're kind of doing validation testing on the first node that we got from this data center company, which is like 8 3080s.
okay.
Lovely envelope, and they got thousands of them. But a couple weeks down the road, whenever it works, like if you would like to see if you can scale Backboot to a couple thousand GPUs, we'd be really excited to make that connection.
Yeah, definitely possible. It's just going to be a matter of basically making the time to write the support for it. Anything that Bacalhau supports natively, Backboot can also support. It's just making sure we'd sort of do it in like a way that makes sense and doesn't like burden the user. So something where Ansible sort of instruments the machine, detects all the GPUs that are in the machine, and then sort of configures itself and then configures Bacalhau. to utilize those GPUs. I think that's sort of fairly simple. It's just going to be, it'll probably just be behind priority of getting like cloud deployment and a few other things going. Although if this is in a matter of weeks, I might just like get the DigitalOcean support going and sort of leave that as the only plugin for now. We're trying to support like all the clouds, basically, like not all of them, but all the major ones. But of course, that's going to be a ton of work. So maybe the priority is going to be to support GPUs once we get, just the one DigitalOcean cloud support landed in it. But we'll play it by ear, and you're always welcome to DM me or talk in Bacalhau and see where it's going or help steer it, because it's an open source project. So,
woo, open source.
Go open
All right.
source.
Yeah, MIT license, and I'm open to other licenses too, but it's
right.
MIT, so it's pretty much do what you want with it.
All right, we'll negotiate. Maybe Apache. We'll see.
I'm open to just dual licensing it and just saying it's MIT/Apache. That's like the Protocol Labs way, is to just dual stack it.
Fair enough. Fair enough. Good stuff. Well, thank you, Benjamin. Thank you so much.
Thank
And
you.
thank you again to the New Atlantis team and the Polybase teams. Tremendous content today. We appreciate it. And we'll see you guys again next time. Have a great day.
Yay, live long and prosper, y'all.
Bye-bye. Cheers.